And so where do you think we need to start to solve this equation? And Rodrigo, I don't know what your view looks like, but if it's not comfortable, you are welcome to move towards the center. Same thing with you, Promise. Just make sure the screen is visible for you guys. So where would we begin on solving this equation? Parentheses. Very nice. Yeah, you want to simplify the parentheses part first. And you know what? Let me get a blank screen here so it'll make the math that I write down look a little bit better. Okay. So let's move this to the top. I'm gonna have this here. Okay. So let's take a look at how to solve this. All right, so we've got 8x minus 2, and we need to do the parentheses part first. So you want to multiply these two first, right? So 5 times 2 will be 10. You have a negative in front, so it'll stay as negative. So negative 10x equals negative 5.6. Okay, so we started with parentheses first. What should be our next step?
It'd be like the like terms.
Very nice. Yeah, combining like terms. So we are going to go ahead and combine 8x with negative 10x. So of course, you're doing 8 minus 10, which will give you negative 2x. You're left behind with minus 2, and then of course, negative 5.6. Now, obviously, you will remember from solving equations, you want to get the x on one side and the constant terms on the other side, right? So you can see we've got the negative 2x on the left, so obviously move the 2 to the other side. Since it's minus 2, when you move it to the other side, it becomes plus 2. Move him, and then you are left with negative 2x equals, what will that be? Negative 5.6 plus 2?
Negative 3.6.
Very nice. Negative 3.6. And then, of course, to get x by itself, since you are multiplying negative 2 with x, remember you do the opposite operation, which means we divide by negative 2. And you will see we are taking the negative sign with the number because we obviously want x to be a positive value. So you've got negative 3.6 divided by 2, which will give us what? And again, remember, I'm not expecting you to do the math in your head. When I ask you questions, don't feel like you have to do the math in your head. You do have access to calculators, so don't feel pressured is basically what I'm saying. So negative 3.6 divided by negative 2? Very nice, and it will be a positive 1.8 because the two negatives will become positive. All right, so let's check that answer. Positive 1.8. So they are only asking you for fractions and whole numbers. So what will 1.8 look like as a fraction? Do we know how to convert 1.8 into a fraction? Yes, no, maybe.
Be 1.14.
Not a mixed number, just a reduced fraction. But you are on the right track. So remember, any number can have a denominator of 1, right? So start out with that. But obviously, the idea is we need to get rid of the decimal. So you would need to move it one place to the right, which means you would do the same thing on the denominator, which means you would then introduce a 0. So 1.8 as a fraction will start out being 18 over 10, and then reduce that. So what would be common between 18 and 10? 2, right? Basically, yeah. So 18 would go into 2 9 times, and of course, 10 would go into 2 5 times. So you will see, Rodrigo, if you took that mixed number and convert it to a fraction, you'd get the same answer. Yeah. All right, 9 over 5. So let's check that. And again, sometimes my open math can be pretty intuitive. So sometimes it may accept a decimal answer, but I'm guessing since they specifically gave us instructions, they want a fraction and not a decimal. So if you want to play around with it, you can, but I would say follow the instructions because that's probably how the problem was designed. Okay. All right. Any questions on just the basics of solving an equation? So is everybody comfortable with this part? Any questions? Okay, all right. So let's clean this up. And let's take a look here. Do we have, this one has fractions with it? Okay, let's tackle the one with fractions and then we'll do some different set of examples. Because I know sometimes fractions can be scary. So let's take a look at what we need to do for this guy here. So of course we can see we are given x times 5/2 x. Sorry, no, I think that's just solve for x period, right? And then 5, okay. I would have put a little bit more space in there. Okay, so my apologies. So you are actually starting at 5/2 x minus 5/16 equals x plus 1/4. So of course we can see there's an x term on the left-hand side of the equation, x term on the right, and same thing with constant terms, right? So you want to try and bring the x's on one side of the equation and the constant terms on the other, and then you want to try and combine like terms. So take a minute and let me know what will the x's combine into when you bring them on one side, and what will your constant terms look like when you bring them on the other side. So basically you will be moving, and I know for some people it doesn't matter, but the way my brain works is I always like my x's to be on the left-hand side. But if you are comfortable having them on the right, that's fine. So do it the way you are comfortable and what makes sense to you. But I will move this guy to the left and I will move this guy to the right. Okay, so combine your x terms and tell me, what do you come up with? And as I said, it doesn't matter if you move it to the left or right, whatever you're comfortable with. What do you get for the x term on one side, and what do you get for the constant terms on the other side? Do you have an answer? Okay, you want to tell me?
53/2x equals 1/16.
1/16, okay. Anybody else can say if they have the same answer or different answer? Same? Okay. All right, so if we did move the x to the left-hand side, you are subtracting x here, which means if you look at the math, you are actually doing 5/2 from the first term, and then since we're doing minus x, you're doing -1, right? So if you're doing -1, obviously since we are dealing with fractions, you need to find common denominators. Now again, if you're using a calculator, it will probably do the math for you, but otherwise you're finding a common denominator, and that would give you 5/2 minus basically 2/2. So once you have that common denominator, then you can do 5 minus 2, which would give you the 3. So that's how you end up with the 3/2 x on the left-hand side. And then for the right-hand side, we would be adding 5/16 and moving it to the right. So of course, these guys cancel out. And then let's see, you are adding 1/4, which was a positive 1/4, yeah, with 5/16. So same thing, right? Common denominator means we would need to turn this guy into 16. And then you would, of course, be adding 4/16 with 5/16. So that should actually give you, do you see that?
Yeah.
What do you think happened? Did you not change the sign, maybe?
I think that I thought because of the fact that it was subtraction over there, then I would have to subtract it across.
Okay,
But
so you kept the minus sign.
yeah,
Okay, so yeah, just be careful with those signs because a lot of times it's not the math, but the signs can create an incorrect answer. So let's take a look at that. So you got 9/16. And I think I showed you this with Desmos last time, but I'll just open it separately to show you the math. So, okay, for just a quick second, I'm going to delete this so you can see the screen better. But if you were doing the first part of the fraction, which was the x values, we were doing 5/2 minus 1. So you can see if you just enter that into Desmos and then change that to a fraction, you would come up with the 3/2. So you can definitely use Desmos to help you with that. And then we were adding 1/4 with 5/16. So obviously by default, it gives you the decimal, but like I said, you can change that to fractions. So you can use a calculator as a backup also to make sure that your math is coming out correctly. So that's just to show you with Desmos. Alrighty. So now we have 3/2 x equals 9/16. Now to get x by itself, how would we get rid of the 3/2? What would we need to do so that we can get the x by itself? Multiply them by what? Do we keep the numbers the same or do we need to do something different? No. So if you are multiplying, you actually flip the fraction. Because remember, the other way is, since technically 3/2 is being multiplied into the x, right? Because it's 3/2 x. Technically, that means we are dividing by 3/2 to get rid of it, right? Because that's how you get rid of the constant term in front of your variable. So either you divide by 3/2, which would obviously end up looking something like, and again, just as a scratch work, I'll show you here. So if you did 3/2 x and you wanted to divide by it, you would divide by 3/2. But remember, in multiplication and division with fractions, when you are actually dividing by a fraction, you can just invert that and multiply, right? Because that then helps you get rid of the term. So you are going to, which I think will be easier, is just invert the fraction and then multiply both sides by 2/3. So you can see 3 on the top, 3 on the bottom will cancel out, 2 on the top, 2 on the bottom will cancel out, leaving us just with the x value. And then, of course, you can clean up the right-hand side. So instead of just multiplying directly, I would first see what can be reduced and then multiply what's left behind. So between the 9/16 and 2/3, what can we reduce or cancel out? So look at the denominators. Will 3 go into 9 or 2? Which one? 9, yeah. So 3 goes into itself one time. 3 times 3 is 9. So of course, 3 goes into 9 3 times. And then what about the 2? Can that reduce the 16? Yeah. So 2, of course, again, will go into itself once, and then 2 goes into 16 how many times? 8. 8, very nice. So let's see, you have 3 times 1 left on the top, which will give us 3. And we have 8 times 1 on the bottom, right? 3/8. Also, the other thing that you can do is check your solution back into the equation. So what we can do is we can plug the 3/8 back where the x is and see if the left-hand side matches with the right-hand side. But before I show you that part, did anybody have questions on how we came up with the 3/8 as the answer? All good? Yeah? Okay, guys, do not hesitate to ask questions if something does not make sense. All right, so we got x equals 3/8. I'm gonna clear this out. So x equals 3/8 is what we came up with. Okay, so this is what I'm talking about when I say you can check your answer. So you can take that 5/2, replace the x with 3/8, minus 5/16, that's our left-hand side. And then on the right-hand side, you have x, which we came up with as 3/8. plus 1/4. Now, again, you do not have to check by hand, so you do not have to do this math by hand. You can again use Desmos to your advantage. So we can do 5/2. We are multiplying, so use parentheses or the multiplication symbol with 3/8. So 5/2 times 3/8, and then from that we were subtracting 5/16. So as a decimal answer, or you can convert that to a fraction, and you can see the left-hand side is coming out to be 5/8. So left-hand side is coming out to be 5/8. Now we need to see what the right-hand side will come out to be. So again, you can do 3/8 plus 1/4, and of course you can see same decimal answer or as a fraction, same, right? So easy way to check that, hey, did we do our math correctly? Is this the value of X that we should be coming up with? So if your left-hand side matches the right-hand side, we know we have a true statement, right? Which means that we have the correct X value. So now we can plug it in. So X equals 3/8. Again, they're telling you to enter it as a reduced fraction, so that should look good. And again, just hit enter and we're good to go. Yeah, all good? Okay. So two different examples of how to solve equations, something straightforward like what we saw in number 1, or something involving fractions as the coefficients. This one you can see is more like a concept question. So they're asking you if you end up with negative 45 equals 45 after you have solved this equation here. 9 times y minus 5 is equal to 9 times y plus 5. What does that tell you? So concept question, I'll let you guys work on that. This one honestly is just a little bit more like question 1, just with more terms. So I will actually let you guys figure that one out too. Honestly, looks very similar. So let's get down to absolute value equations. So before we get into the absolute value part of this, or solving the equation, what do you guys know about absolute values? Like if I gave you the symbol, the absolute value with the number in it, what does the absolute value tell you? What do we know about absolute values? So if you have absolute value of, I don't know, 7, and absolute value of -7, what does this tell you?
Would be the total value of the number without looking at the sign in front of it.
Okay, so what will the absolute value of 7 give us?
7.
Okay, an absolute value of -7?
7.
Okay. Why does that happen though? Why did the -7 also give us an absolute value of +7? Anybody? Because they're not the same numbers, right? There is a +7 initially, which stayed +7, but then -7 became +7. So what makes that happen? Obviously, the absolute value is what makes it happen, but what's the reason behind it?
That's the total value from 0.
Very nice. It is the total value from 0. So you can think of it as the distance from 0. So if you look at the number line, 0 falls in the middle. We're going towards positive numbers on the right. We're going towards negative numbers on the right. And the infinity symbol just tells that it keeps going, right? The numbers just keep growing. So if we're talking about 7, we're saying 1, 2, 3, 4, 5, 6, 7. That's +7. 1, 2, 3, 4, 5, 6, 7. -7, right? And then of course the numbers will keep growing from there. But basically we are saying how far is that number from 0? And of course you're going 7 units, right? So think of a distance of 7. Same thing if you are going the other way. So 1, 2, 3, 4, 5, 7. So you're still going a distance of 7. So, think about it like when we talk about direction, since we're in Fort Lupton, let's say we were going down to Denver, we wouldn't really say we're going negative, whatever, 20 miles to Denver, right? You would just say I'm going south. Or if you were going up to Greeley, we wouldn't say I'm driving positive 15 miles or whatever the distance might be, right? Same thing with east or west. So we don't really use positive or negative when we're talking distances. We would just say, hey, I'm driving 10 miles to get to wherever I need to get to. So that's what absolute value does. So yeah, like you said, it's that distance from 0. What is the absolute value or the total value that you need to move from 0? So that's why the positive stays positive and the negative becomes positive, because we're just talking in terms of distances. So this is kind of crucial to remember. And I think I had mentioned this, or maybe not in your class. Did I talk to you guys about square roots? Have we talked square roots yet? Kind of. So remember, anytime you take the square root on a number, you can get a positive or negative root. It's the same way when you are solving a absolute value equation, because we don't know what direction the answer could be in, right? Is the answer for X going to be on the right-hand side of the number line, or is the answer going to be on the left-hand side of the number line? Whenever you are solving an absolute value equation, you have to take that into consideration, that I could come up with a positive answer, or I could come up with a negative answer depending on what side of the 0 on the number line you're going to be. So when we look at something like this equation here, so let's clear this out. So you're given absolute value of 1 plus 2x inside the absolute value symbol, and then you have plus 30 equals 10. So the first thing you actually do when you're working with absolute value equations is isolate the absolute value symbol. So anything that is outside of that absolute value symbol needs to be moved to the other side of the equal to sign. So in this case, of course, that would mean moving the 30 to the other side. So you would then be left with absolute value of 1 plus 2x equals 10 minus 30 will give us what? Very nice, negative 20. So this actually creates an interesting situation for us, because if we are talking about distances, can distance be 0? Can distance technically be 0? Exactly. If you're not moving, so if I'm just standing here, I'm not going anywhere, I'm at distance 0, which is my starting point, right? If I start walking, then I've covered some distance. Distance obviously can be positive, right? Like we were talking positive 10 miles, positive 20 miles. Can distance be negative? Can I go in a negative distance, I guess? And I'm not talking north, south, east, west. But can the value of distance be 0, less than 0? Yeah? How? It cannot, can it though? Because if 0 is stationary, you're not moving, how do you go negative? Unless I guess I'm getting sucked by the earth.
Yeah, you go down.
And then I just stop to exist. Because technically, even if you were drilling down, that would still be a positive distance, right? Like you would say, I drilled.
Going into the earth at X amount.
Yeah, but that's still a positive distance, right? Like you would say, I dug. I guess dug is what I was looking for.
Can you have negative coordinates then? I don't know.
You can have negative coordinates because it's a coordinate plane. So there's a
Okay.
0 coordinate and then there's the positive and
Because
negative.
it still tells you direction, right? Like if
Right.
you have a negative coordinate, it could mean like you're going on the other side of the, whatever the standard mark is, right? But your distance cannot be negative.
Yeah, because if you're going in like a distance into a negative coordinate, you're going to the negative coordinate.
you're still, like,
going a positive
Moving in
distance
a
to get
direction,
there.
right?
Yeah.
Right.
But negative you cannot. So that's actually what you have to be careful about when you're dealing with absolute value equations. anytime you get this situation where you have an absolute value equal to a negative number, that right there tells you there is no solution to this equation. Because how can distance be negative 20? Distance can be 0, distance can be positive, but distance cannot be negative. So this guy actually has no solution. Because as soon as you see that negative number on the right-hand side, that's it, you're done. So this one will actually be, does it say? Yeah, you can do no solution. And I'm just gonna do a copy paste here. So Teresa, does that make sense why we couldn't have a negative? Yeah, anybody else have a question on this guy? Why we couldn't solve it any further? All right, so this did not go how I wanted it to go. Do we have another example? Yes, we do. All right, let's clear this out. Let's take a look here. So this is of course just asking you to evaluate the value of the absolute value here. This guy, they say has two solutions, so let's check him out. If it has two solutions. All right, so let's see, we have absolute value of 6x minus 6 equals 6. So in this case, the right-hand side is a positive number, right? Which means we can actually solve this guy. It's only when that number on the right is negative, we stop. Even if it's 0, you can solve it. So 0 positives, we can solve the equations. Negative is when absolute value equations cannot be solved. So this is the scenario I was talking about. Now, because we don't know, is the value of our x going to be on the positive side of the number line, or is it going to be on the negative side of the number line? We do need to set this up as two different equations. So when you are solving absolute value equations, the first one will be 6x minus 6 equals 6. So pretty much we just drop the symbols, right, for absolute value. Or since we can be on the negative side of the number line, you will actually set the second half of this equation as 6x minus 6 equals negative 6. Here, using the negative is fine because we're not using the absolute value symbol anymore. We're just saying, is the answer on the right side of the number line or on the left-hand side? And then, of course, solve these like you would any equation. So we start by moving that 6 to the other side. So we'll add 6 to both sides of our equation, which will leave us with 6x equals 6 plus 6 is 12. On the other side, you have 6x equals plus 6 minus 6 will give us 0, which is fine. And then get each of the x's. So what do you get for the x value on the left-hand side and for x value on the right-hand side? So 6x equals 12 or 6x equals 0. What are your x values coming out to be?
2 and 0.
Okay, 2 and 0. So for the left-hand side, we'll divide both sides by 6. And you end up getting 12 divided by 6, which will give you 2. Or same thing, divide by 6 here. But since you are doing 0 divided by 6, it gives you x equals 0. So you can get x as positive 2 or 0. And then remember, as I was saying, you can check your answers to make sure that we did the math correctly. So right now we have x equals 0 or 2. So let's do a quick check and make sure we did that correctly. But before I go to the checking part, is everybody okay on how we came up with 2 and 0? Yeah? All right, so let me erase this guy. Okay, let's check. So we have absolute value of 6 times x. We can replace it with 0. And remember, we're looking for true statements. So we should get 6 equals 6 if the answer is correct. So obviously 6 times 0 will give you 0. You're doing 0 minus 6, which will leave us with negative 6. And as we mentioned before, since we are talking distances, -6 will become +6, right? So you end up with 6 equals 6. That's a true statement, which tells us 0 is in fact a solution for this equation. Now let's check with 2. So again, 6 times x will become 6 times 2 minus 6 equals 6. 6 times 2 is 12. 12 minus 6 will give us 6. And of course, again, since we're talking distances, absolute value of 6 is also 6. And we've got another true statement, which tells us we did good on those solutions. So yeah, 0 and 2, both of them will work. And they didn't really give us any instructions. So I'm just going to try by separating the two answers by using a comma. There's no space between the two numbers, just a comma, and looks like it's saying invalid use of comma, syntax incomplete. Okay, so that's not working. Do you want me to do this?
Well, are you supposed to?
Oh, sorry, it's saying the sum of two solutions. Okay, I did not read that part. Okay, so it's saying sum of two solutions. So you're actually adding the two numbers. You're not just putting the answers separately. So obviously that means you're just doing 0 plus 2 and then putting the total as your answer. So that's why it wasn't accepting mine. All right, not a problem. So just add the two solutions. I forgot that this problem does that. So yeah, just add the two numbers and you're good to go. So again, if one of them would be negative, then you would just add whatever that total comes out to be and you get your answer. Oh, this is the one that wants us to separate with comma. Okay, sorry about that. Are we good on whatever that number was, number 9? All righty, let's erase this. And do not automatically assume you cannot solve number 10 because you have a negative on the right-hand side. Because remember, you have to isolate the absolute value symbol, which means you would start by moving the 2 to the other side. You would get rid of the -6. And then you see, do I end up with a negative or not on the right-hand side? So isolate the absolute value of x and then see what the equation comes out to be. So I'll let you guys work on that. This one looks very similar to what we just did. Let's do number 12. That's the best setup I can do. So we've got 1 minus 2 times the absolute value of -6x plus 15. Sorry, plus 5. 15's on the other side. Plus 5 equals -15. So same thing, right? We cannot assume just because we have a negative on the other side that this cannot be solved. Let's clean it up first and see what we come up with. So order of operations here again, guys. So basically that -2 is being multiplied into the -6x plus 5. So we cannot do anything with this right now. Leave it as it is, but you can see that 1 is a constant number. It is a positive one, which means when you move it, we'll need to subtract it. So you are actually going to start by subtracting that 1, which will get rid of it from the left-hand side. We will be left behind with -2 times the absolute value of -6x plus 5 equals, of course, you're combining -15 with -1, and what will that give us? Very good, -16. Now, since that -2 is being multiplied with the absolute value symbol, remember to get rid of it. If it's multiplication, you use division. So you are actually going to divide both sides by -2. So that will help us get rid of that coefficient in the front, leaving us with the absolute value itself. So absolute value, excuse me, of negative 6x plus 5, which is what I wanted, right? We wanted to isolate the absolute value symbol. Now we have, but now you will see on the right-hand side, because we have two negative signs, they cancel each other out, become a positive, and then of course 16 divided by 2 is going to be 8. So you did actually end up with a positive number on the right-hand side. So obviously that tells us now we can solve this equation. Okay so far? Yeah? Wonderful. So now let's solve negative 6x plus 5 in the absolute value symbol equal to 8. So when we set this up, sorry, I need to either write small or use a bigger space, but I will actually delete that. And let's move him on. So I can get more space here. All right. So again, when you set this up, remember you do it once positive, once negative. So this will then end up becoming negative 6x plus 5 equals positive 8, or negative 6x plus 5 equals negative 8, right? So one's positive, one's negative, and then you're just solving this like any other equation. So we want to get x by itself. We start by moving the 5 to the other side, which will leave us behind with negative 6x equals 8 minus 5 is 3. What will your x value come out to be on this side? And then same thing on the other equation. We start by subtracting 5. We are left behind with negative 6x equals, now you are doing negative 8 minus 5, which will give us what? Negative 8 minus 5. Yeah, very good, negative 13. And then of course you want to get the x for the other side. So let me know what our two x values are coming out to be. Promise you have not been answering. Are you okay? Are you with me?
Yeah.
Yeah, okay. So what are those two x values, guys? Looks like they'll be fractions, right? Because they will not simplify. So what do we have? Do you have an answer for me? On the first equation, what will we get for the x value? Positive, negative.
That side,
Left hand side, yeah.
positive,
Positive?
yeah,
Okay.
because you're gonna minus the negative 6 under the 3.
But since you are actually multiplying negative 6 with x, we divide, right? To get rid of it. You will actually see the negative sign will stay because 3 is positive, right? So since you're doing positive divided by negative, it will stay negative. And then of course 3 and 6 will reduce down to 1 over 2. So the left-hand side will actually retain its negative sign. What x value do we get from the right-hand side?
Positive 13 over 6.
Yes, because here we will have two negative signs. So in this case, the two negatives will cancel each other out. 13 and 6 will not reduce any further. So they will turn into positive 13 over 6. So again, I showed you if you needed to check your answer, how you can do that. And again, remember, if you want to use the calculator to check it, you can. I will actually go back and make this guy larger. So you will see this one, they are actually asking us to separate the answers with a comma. So let's try that. We have negative 1/2. So comma and then 13 over 6. Okay, no more error showing up. So that should hopefully, yeah, the right answer. Yeah, questions? Okay. So this is solving equation. So you saw linear equations at the top, and then these ones were, of course, working with absolute value equations. So going to exit this guy. And move them into factors and multiples, because being able to factor stuff is also going to be a crucial part of, as we move forward with the concepts with college algebra. So we, of course, want to make sure we are comfortable factoring numbers. So you can see we're kind of going back to prime factorization. Now, when we are talking about prime factorization, of course, we're saying breaking the numbers down into prime numbers. So remember, by definition, when we're talking about prime numbers, we are saying numbers that can be broken down into the number itself and one, right? So like 2 is 2 times 1, 3 is 3 times 1. But 4 is not a prime number because 4 can be broken down into 4 times 1, but also 2 times 2, right? So it can be broken down further than just the number itself and 1, the product of, the number itself and 1. So you can see here they're giving you the example of 12. So I like to use factor trees when I'm working with prime factorization because 12, of course, you don't want to start with 12 times 1 because you're just repeating the number, but you can use any other combination. You can do 6 times 2, or you can also start out with 4 times 3. Now, as soon as you hit a prime number, that branch closes, and then you keep going. So 6 will be 2 times 3. So again, you hit the prime number, that branch closes. On the other side, you have 4, which is 2 times 2. You get to the prime, it closes. But then you look at all the prime numbers that you have. So from the first left-hand side, we got 2, 2, and 3. And from the right-hand side, same 3 numbers, right? 2, 2, and 3. So you can see your prime factorization will still come out to be the same, but it doesn't matter where you got started as you were breaking down the number. So that's kind of why I like using factor trees when we're working with, these kind of problems. So let's see how we can find the prime factorization for 240. Let me get my little Word document here again. There we go. All right, so we're breaking down 240. So how do you think we can break down, like what would be that first step of 2 numbers that multiply to give us 240? Or just think 24.
Just at 24 and 10.
24 and 10, hey, that's a great place. Yeah, because you do have a 0 at the end. So we know this number will go into 10. Neither one of those are prime numbers, which means we need to break them down further. So let's start with 10 because that's going to be quick. What can we break down 10 into? There you go, 5 and 2. And both of those are prime numbers. So those branches will end right there. Then you can move to the other branch with 24. And what would you use for 24? Okay, very good. 8 and 3. There we go. 8 and 3. So 3, of course, is a prime number. We stop right there. 8 will continue down. 4 and 2. So 2, of course, will close again. And then what about 4? 2 and 2. Okay, so let's list all the prime. And I do like to go in order of smaller to larger, but my open math may not be that particular. So I'm seeing 1, 2, 3, 4 of the 2s. So 1, 2, 3, 4. I'm seeing 1, 3, and 1, 5. So 2, 2, 2, 3, 5, 2. Yeah. And you can actually use exponents to write any repeating number. So since we have 4 of these guys, you can write it as 2 to the 4th power times 3 times 5. And when in doubt, again, you can just do a quick check on your calculator. So we had 2 times 2 times 2 times 2, 4 times. times 3 times 5, and you can make sure that does come out to be 240. Alrighty, do you want us to use exponents for repeated factors? Yeah, so they are telling us to do that. You can do that 2 as your base, and you can see this will be your little exponent option. So 2 to the 4th power times, and I'm just using the asterisk key on my keyboard, times 3 times 5, and hopefully that should look good. Yeah? Questions? Some rules of multiples might be nice to remember here. So like we kind of landed on it by default, right? If a number is ending in 0, we know it will be a multiple of 10, which means you can do 10 times something to get to that number. If a number is ending in 5, then 5 will be one of its multiples. So like if you look at your question 2 over here, since this guy is ending in 5, 5 will be one of the multiples. You can do 5 times something to come up with 385. Same thing with this guy, it's ending in 5. The rule for 2's is if it's an even number, right? So all even numbers can be divided by 2. Does anybody know what the rule is for 3? How do we know if a number can be divisible by 3? If you add the digits of the numbers, so let's go back to 240. If you add the digits in your numbers and that total is something that can be divided by 3, then the original number can be divided by 3. So if you look at 2, 4, I mean, of course, 0 doesn't do anything, but it adds up to 6, right? 6 is divisible by 3, and of course, we saw 3 was one of the factors for 240. If you look at 385, what does this guy add up to? 3, 11, 16, right? So 16 will not go into 3, which means 3 will not be a factor for 385. 101.25. So what does this add up to? What does this add up to? 9. So that actually tells you this number can be divided by 3. So that's the, I think it's called divisibility rule. I think that term just was not coming to my mind, but yeah, divisibility rules. So these are some of the basics. Now there's for 7, if I remember correctly, and we might have to Google this, I think it's if the last 2 digits go into 7, then the whole number goes into 7. Divisibility rule for 7. The last digit, okay, so just the last digit of the given number should be multiplied by 2, then subtracted with the rest. Huh, I do not remember that. Oh, apparently there are multiple different ways of trying to see if a number can be divided by 7. So I may not worry about that, but I think that's a good starting point is for 2, 3, 5, and 10, right? At least that kind of gives you a little bit of an idea of how to break this down. So prime factorization, this one seems to be giving you guys a hint also, which looks similar to the hint you had in question number 1, but let's tackle 101.25, 10,125. If we did have to factor this, I would definitely start out with 5. So 101.25 would be 5 times something. And again, guys, you can use a calculator to help you out to start by 101.25 divided by 5 and see where it takes you, right? So you can see it's coming out to be 2025. Of course, the 5 is a prime number, so that branch will end right there, but 2025 will also be divisible by 5. So you can see, okay, 2025 divided by 5 will give us what? Now you can type that whole number in, but also remember you can use that answer key on your calculator because the answer key stores whatever the last solution you came up with. So I can just click on the answer key and it gives you that 225. And again, we're dividing it by 5. Comes out to be 405. So of course, that also can then be further broken down into 5 times something. So 405 divided by 5. So it looks like you're doing a whole bunch of 5s in here. All right, and then we come up with 81 when you do 405 divided by 5. So of course, 81 will not go into 5. Is he 2 at the bottom there? Okay, let me move this guy a little bit upwards. Okay, so 81 can be broken down into what? 9 times 9. And then, of course, we would have to further break down 9 times 9. So what will 9 be broken down into?
3 times 3.
Very good. So, of course, we will get a whole bunch of 3s and 3s from here. So let's see, we've got 3 to the 4th power. And we've got 1, 2, 3, right? 5 to the 3rd power. And that should be your prime factorization for 10,125. So let's see, 3 to the 4th power multiplied with 5 to the 3rd power. Yep, 3 to the 4, 5 to the 3rd. Questions? So just be patient, because obviously the larger the number, the more breakdown it may need, depending on what the number is, but eventually you will get to your prime factorization. So where does prime factorization come into play? A lot of times we use factorizations to basically work with least common denominators, right? So a lot of times we have to find what the common denominator would be. So instead of working with them as denominators right now, we're just working with numbers individually. So we're calling it least common multiple, but obviously that's where the least common denominator comes into play. So remember, by least, what we are saying is you have a whole list of common numbers between, whatever your original numbers might be, but we're saying out of all the common numbers, which is the smallest one, right? So that's where the least comes into play. So if we look at something like 6, 14, and 8, or 6, 8, 14, how will that break down? Come on, my dear. All right, so we've got 6, 8, and 14. So the idea is there has to be one number large enough that can be evenly divided by 6 and 8 and by 14. So what number would go into all of them? So you can just kind of sit and think about it, or we can use the idea of prime factorization to help us out. So we can take 6. 6 is broken down into 2 times 3, right? We can take 8. So you know what? Let's get rid of this. So 6, of course, is 2 times 3. 8, you can start out with 4 times 2, and then 2 times 2, right? So that will actually be 2 times 2 times 2. Then you have 14. 14 can be 2 and 7, which both of those are prime numbers. So you can get 2 and 7. So start out by breaking down whatever those numbers are into their prime factors. And then we can find the least common multiple or least common denominator, depending on, what problem you are working on. So let's take a look here. If I needed to find my least common multiple, what you do is you look at all the numbers, look at all their prime factorizations, and you will see all of them have a 2 in common. So you actually only write that 2 down once. And then, because this is a least common multiple, everything else that was remaining needs to also be copied down. So you can see we have 2 of these 2's here, bring them in. You have a 3 here, bring that in. You have a 7 here, bring that in. When you multiply all of these numbers, you get your least common multiple. So that will be 2 times 2 times 2, which is of course 8, times 3, times 7, and looks like it's going to be 168. Hello. And you can actually, again, check that, because I can take 168 divided by 6, and you can see it evenly divides. I can take 168 divided by 8, and that works out, and 168 divided by 14, and that works out also. So each of those numbers will individually divide into 168. So 168 is going to be your least common multiple. Questions, guys, on how to find these? So this is the easiest way, because the other way would be, you look at 14, which is the largest number, and you keep going through multiples of 14. So 14 times 2, 28. Does 28 go into 6 and 8? No. Then you move on to 14 times 3, 14 times 4. But as you can see, that can take a little bit of a long time till you reach a number which can be divided by 6, 8, and 14. So it actually makes sense to kind of break it down into its prime factors and then go from there. Let's do one more example on this. So let's do 16 and 18 more. Okay, so 16 would break down into what?
4, 4.
Very good, 4 and 4. And then, of course, you can break down 4 and 4 further as 2 times 2 and 2 times 2. So actually 16 is 2 times 2 times 2 times 2, right? 4 of those. Then you had 18. What can we break 18 down into? What combination would we start with?
9 and 2.
Okay, 9 and 2. So of course, 2 is your prime number. Break the 9 down into 3 times 3. And 18 will break down into 2 times 3 times 3. So in this case, you can see for your least common multiple, one of the 2's is common between both the numbers. So you write that down. And then basically everything that's remaining. So 2, 1, 2, 3, 1, 2, which will be basically 16 times 9 that we're looking at. $144 is going to be our least common multiple. Out of 144 being divisible by 16, huh? 9 times, okay, which makes sense. And then by 18. By default, 144, I always go to 12 times 12, right? Because of the perfect squares. That's interesting. Okay, I learned something new today. Questions on finding least common multiples. Now remember, this same exact technique you can use when you're finding least common denominators. Okay, the other thing we can do with prime factorization is finding the greatest common factor. And this will definitely come into play when we are solving
You can ask a bit about the last one real quick before we move on.
the 1618.
Yeah, it's really, really quick. When you go to the least common multiples and you do like 2 times 2 times 2 times 2 times 3 times 3 times 3, what makes you choose like the numbers? You know what I'm saying? Like the first two, like the common multiples, they're like all of them, like the 2 from the 16 and the 2 from the 18, do those group together and are those the first one and then you add everything else up?
Pretty much, yeah. Yeah, so because the idea is they're both common, right? So instead of writing it twice, if you write it only once, you're not gonna get, because remember, you're going for the least common multiple, right? So we're saying out of all the common numbers, we want the smallest one. So by not repeating this, you are making sure you're getting the lowest number, which will be common between them. So yeah, whichever one is common, you only write it once. And then everything else that was not common, you list everything else
That
after
also
that.
works with like multiple numbers, like with the last one as well, right? That goes with multiple numbers. You group the smallest one together as one.
Yeah.
And add the rest.
Yeah, so like if you had, let's do 4 and 8, let's say, for example. So if we were trying to find the least common multiple between 4 and 8. 4 would be 2 times 2, 8 would be 2 times 2 times 2, right? So when you list these out, you would have 2 and 2, you would have 2, 2, 2. So now when you find your least common multiple, you would have 2 of these that are common, right? So then you would take the 2 of those that are common and then whatever is
And
left
then whatever.
behind. So in this case, and it makes sense, right? That the 8 would be the least common one because 4 can be divided into 8 and 8 into 8 is 1.
So the ones that are grouped up, you just write them once.
Once, yeah,
Okay.
very good. I'm glad you asked that, yeah. Any other questions on this? Okay, all right, awesome. Now, greatest common factor goes in the other direction because greatest common factor, you really only want what is common, which means unlike the least common multiple where we took everything else which was also not common and we multiplied it, in greatest common factor, you only look at what is same between all the terms, but leave everything else out, which is not common. So greatest common factor, so if we look at this guy over here, I'm actually going to break these terms down individually. So you've got 4, 6 to the x power, y to the second power. We've got 8 x to the 5th power, y to the 3rd power, and you've got 20 x to the 4th power, y to the 4th power. So we first need to find the greatest common factor just between the numbers, even before we get to x and y. So in this case, I'll do the same thing that we did with LCM and break each of the numbers down into their prime factors. So you can see 4 will break down into 2 times 2, and then of course you have x to the 6th, y to the 2nd with that. For the 8, 8 of course breaks down into 4 times 2, and then of course 4 breaks down into 2 times 2, so you of course have 2 times 2 times 2, and then x to the 5th power, and then y to the 3rd power, right? So that's the 8. And then the last term we had was 20, x to the 4th, y to the 4th. Now 20, again, you can start, wherever you like. So what would be a good place to start for 20? Sure, 2 times 10. So of course, 2 being a prime factor will stop right there. 10 can be 2 times 5. So we have our prime factorization, which comes out to be 2. Okay. 2 times 2 times 5, and then of course you have your x to the 4th, y to the 4th. So now when you are finding your greatest common factor, you only look at what is common. So all 3 of the numbers have a 2 in common. We'll go ahead and list that. They actually have another 2 in common. So we'll go ahead and list that. And then you will see you had a 2 left over in the 8 and a 5 left over in the 20. We've used both the 2's from the 4. But this is the greatest common factor, which means anything that's not common does not get included. You leave it out. So only 2 times 2 will go into the GCF. Now, when it comes to the variables, the x and the y, you go with the smallest exponent value because you cannot go with the larger one because this has 6 x's, but the second number only has 5 x's and the last number only had 4 x's, right? So how many 4's, how many x's are common? And that's 4. Each of them will have a 4x. So you are then going with the smallest exponent. So for the smallest exponent, it's going to be x to the 4th power. And then let's see, you have y to the 2nd, y to the 3rd, y to the 4th. So of course, y to the 2nd is going to be the smallest one. Now, I can also show this to you in a different way. Let me actually create some space here. Oops. Okay. The other way you can look at this is if we take all of these numbers. Okay, so instead of writing it out as x to the 6th or y to the 2nd, what you could have also done is, okay, I will actually need to erase these. 2 here, this guy was a 5. So again, you had x to the 6, which technically, I'm just going to put a 1 there to hold that space so that I can line up all my x's. So you have x to the 6, so that's 1, 2, 3, 4, 5, 6. And then you had y to the 2nd. Then let's see, you had x to the 5th for the next one. So that's 1, 2, 3, 4, 5. And then we had y to the 3rd. So 3 of these guys. And then for the last one, you had 1, 2, 3, 4, and 1, 2, 3, 4. So same idea you can use here. You can see 1, 2, 3, 4 of these are common, right? So that's where the x to the 4th is coming from. And on the y terms, you can see 1 and 2 are common because then it's a combination of either x's or y's or both of them, right? So then you have nothing common between all 3 of them. So you can expand out your x and y, but it still gets you to the same result. So for the x and y or any of the variables, go with the smallest exponent. But then as far as the numbers are concerned, only go with those that are common to all 3. And then whatever is not common, you leave it out. Yeah? So then when we multiply this, of course, we will then end up with a GCF of 2 times 2 is 4, x to the 4th, y to the 2nd. And we can put this guy in here. So 4 x to the 4th and y to the 2nd. 4 x to the 4th, y to the 2nd. Let's check that. And he looks good. Let me know if you have any questions on this guy. So slight difference between how you do a least common multiple and how you do a greatest common factor. Least common multiple, we would have taken all the uncommon terms also and put that in. with greatest common factor, you only look at the common stuff. Anything outside of that gets left out. All right, greatest common factor. Same thing here. Same thing here. Same thing here. Did you guys want to see another example of GCF, or are we okay? Okay, anybody else wants to see an example? No? Okay. And obviously, if something comes up and you need my help, don't hesitate to ask, but this guy was 0.3. Okay. This should be similar to what we had done in solving equations. The only thing here you would have to do is make sure you are matching the terms, right? Making sure, especially when you're working with exponents. So let me see what we have. Exponents. And then some operations. Okay. Can you tell me from number 1, which ones are the like terms here? Want me to make it bigger?
Oh, no.
The one with the same exponents.
Very nice. So that would be which terms?
That's 6x to the 6 and the 4x to the 6.
Very nice. Yeah. So you're not matching the coefficients, right? You're just looking at the variable and the exponent on that. So 6x to the 6th and 4x to the 6th will be like terms. So of course, then we can combine them together. 6x to the 6th was positive. 4x to the 6th was positive. So that will come up to be what?
6.
Very nice. 10x to the 6th. And then do we have any other like terms in that expression?
Second.
Perfect. So 9x squared and 7x squared, because again, you have both of them with x squares, so you can combine them together. So 9x squared is also positive, 7x squared is also positive. So what are we looking at as a combination here?
16.
Perfect, 16x squared. Is there anything that is common that's left? No, but obviously we cannot ignore the 5, so we would need to include the 5 in our final sum as you add these together. And again, usually you go from the largest exponent to the smallest. So we would be putting 10x to the 6th. All of these terms were positive, so you will have plus sign between all of them. So 16, small x squared. There we go. And then the plus 5. So again, basically, we combined the like terms. That gave us the 10x to the 6th. Then we combined the 9x squared with the 7x squared, which is where the 16x squared came from. And then you were left with the 5, which of course needs to be put at the end because that was the only one that did not have a common term to combine it with. And we can check our answer and you are good to go. Right, so combining like terms. And like I said, we kind of did something similar when we were seeing how to solve our equations in the previous 2 sections. All right. So he's done. So I'm not going to solve this one because I would like you guys to do that. But just as a starting point, where would we start on this example? With the 1/3 x plus 1/7 parentheses x plus 20. Very nice. So order of operations here again, right? So we would actually start by simplifying the coefficient outside with the parentheses. So you would actually start by multiplying that 1/7 into the x and the 20. Does anybody know what this property is called? The distributive property, right? Because you're distributing the 1/7 inside the parentheses. So of course, then you would have the 1/3 x would stay as it is, and then you are multiplying the 1/7 with the x, and you are multiplying the 1/7 with the 20th, which technically, if you think of that as 20 over 1, this guy can become 20 over 7, right? And then you would go ahead, use the same idea of combining like terms, and then simplifying your expression. So like I said, I'll let you guys work on that one. All right, so we are actually getting into rules of exponents over here. So just to refresh your memory, whenever you are looking at the same base with different exponents, so as long as the bases are the same, right? This is what we call as the product rule, because since you are multiplying the two bases, the rule is you end up adding the exponents. So you would do m plus n. So using that over here, what do you think we will come up? You're adding. So 13 plus 5, right? So what did you say?
X to the 18th.
Oh, I heard 15. I'm
Oh.
so sorry. So that's not adding up. Okay, sorry, my bad. So yeah, you're adding 13 plus 5, which will give you 18. And again, if you think about the math behind it, you're basically saying I have 13 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then you are multiplying them with 5 more, right? Which means you are basically just putting 5 more. And if you add all of them, that adds up to 18 of these x's, right? So you get x to the 18. But obviously, instead of doing that whole mess, we can just add the exponents and we are good to go. All right, so x to the 18th exponent to the 18, and you are good to go. So this is based on the product rule. Number 4 here comes from the power rule. So for the power rule, the idea is when it is the same base with 2 different exponents, you've got one on the inside, one on the outside. Technically, you are actually multiplying those exponents. So you are doing m times n. So single base, but with 2 different exponents. In this situation, like I said, this is called the power rule. You just end up multiplying 7 times 9. So what will that give us? Very nice. So a to the 63rd power.
And what did you say was the name of the other rule?
The first one?
Yeah.
Product.
Product?
Yeah. You're welcome. So this guy is a to the power of 63. Number 5 is actually combining 2 different rules in it. If I can get him to be visible here. So what number 5 is actually doing is using the quotient rule and the 0 exponent rule. 0 exponent rule is actually pretty straightforward. Any base that is raised to a 0 power actually ends up becoming 1. So a to the 0 will just become 1. Actually, it's not even quotient rule because you have x on the top and y on the bottom, so we cannot even combine those. Yeah, so no, just the zero exponent rule. Now, here's the crucial thing you have to make sure you understand. The entire fraction is inside the parentheses, right? And then the zero outside, which means that zero exponent is applying to everything that is inside the parentheses. So technically your base A is going to be that fraction 4x squared over y squared. So that entire expression being raised to the 0 power will actually just end up becoming 1 because there's no simplification we can do since the whole thing was inside parentheses. So this guy will just be the 0 exponent rule, and you come up with 1. All right, there we go. Number 6 is where we will use the quotient rule. So what exactly is the quotient rule? So for the quotient rule, the idea is kind of like what we had done in the product rule. So with product rule, you are adding. Quotient rule, we're saying you're dividing the same base with different exponents. So here, you actually end up subtracting them. But before that, we would kind of have to use the distributive property for the exponents also. So what that means is if you have two different bases inside the parentheses with the same exponent, that exponent applies to everything that's on the inside of your parentheses. So you would have a to the power of m and b to the power of m. So that exponent again gets applied to everything, which is exactly what happened when we were looking at the previous example where you had this guy become 1 entirely because that 0 applied to the 4, to the x squared, and the y to the 0. So technically what we could have done with this guy here is we could have said, okay, that 0 applies to 4, so that becomes 4 to the 0 power. The 0 applies to the x squared, so you would have x squared raised to the 0 power. And then the denominator, you had y squared, so that 0 applies to the denominator also. So each one of them individually would have received the 0. So 4 to the 0 becomes 1, x squared to the 0 becomes 1, y squared to the 0 becomes 1. And you can see we still end up to the same answer, right? So you can kind of break it down that way also. But like I said, since the whole thing was in parentheses and the 0 on the outside, we didn't really need to use that distributive here, but it works in the same way. So let's look at the next one. How do we break that guy down? Okay. So 2d whole thing raised to the 8th power, 2d raised to the 18th power. Now 2d and 2d is the same between the numerator and denominator. So technically, we can apply the quotient rule because the base is the same, right? It's 2d and 2d. So you can actually go directly into the subtraction part of it. So we can say, okay, 2d is my base, and I have 8 on the top, 18 on the bottom. Now that order is very important because m is on the top, n is on the bottom, and you're doing m minus n, which means the exponent from the top minus the exponent from the bottom. So don't worry about which number is larger or smaller. That does not apply here. Top minus the bottom exponents. So what is 8 minus 18? Very good. But in this case, will it be positive, negative? Negative, right, because we're doing 8 minus 18, so negative 10. So that actually then leads us into the negative exponent rule. The negative exponent rule is if you have a base with a negative exponent to make it positive, since a to the minus m is technically in the numerator, to make that m into a positive m, you move it into the denominator, and you do that by just using 1 as your numerator value. So 1 over a to the m, and it also works vice versa. If you had 1 over a to the negative m, since it's in the denominator, you can move it to the numerator to make it positive. So just move from numerator to denominator and the exponent becomes positive. So this is the negative exponent rule. And did they say how they want us to write this? They're just saying simplify completely. So since we did have a negative exponent, we would have to move it to the denominator, which means then you would have 2d to the 10th power. I'm gonna try and see if this is right, or do they want us to do 2 to the 10th power and multiply that out? So since they don't exactly have, I'm going to see if this works. So 2d raised to the 10th power. Huh, I really did not think it was going to accept it, but I guess it did. So just simplify it to where you have a positive exponent. And that is one of those rules we assume is always to leave your exponents with a positive value. So you wouldn't want to leave it with the -10. Yes.
Is it the same if your base, like the 2Ds, like let's say like those 2Ds were two different numbers or different Ds? Would it be the same or no?
No, then the process would be different, because if the base on the top and the base on the bottom don't match, we wouldn't be able to use the quotient rule.
Okay.
Then you would actually have to distribute the exponents like we saw before and then go from there. So yeah, because the bases were the same, they were both 2D and 2D, we could do this. Okay, I'm glad you asked that. Any other questions, guys? Okay. So this was quotient rule. You know what? I'll let you guys try 7 on your own, and if you get stuck, obviously I'll be here to help. So just as a quick summary, here are the different rules that we talked about. So you have your product rule here that we talked about, the quotient rule here. This was the power rule, the zero exponent rule. I honestly don't know if this guy has a formal name. I just call it the distributive property of exponents, because you are distributing it throughout the base, and then the negative exponent. And it definitely will come in handy to have these, review these so that you are able to use them when we move on to chapter 1 onwards. Find the difference, find the sum, FOIL. Let's do the difference because there's something I want to do in terms of finding the difference here. Okay. So obviously, you can see we have parentheses with the expression -6x squared plus 6x minus 1. And then we have minus because we're subtracting the two expressions. And then the second expression is minus 62x squared minus 25. Now, obviously, in front of the first parentheses, there is no number or no sign. So you can actually drop those parentheses without having to do any math. But in front of the second set of parentheses, you do have a minus sign. So we have to be careful about that. If that was a plus sign, these two signs here would not be affected. But because this is a subtraction, a minus sign, you actually want to treat it as a negative sign and then use that. So you're kind of like distributing that into your second set of parentheses. So let's see how we would need to break this guy down. So like I said, the first set of parentheses did not have anything in front of it. So you can just drop the parentheses. So we would have negative 6x squared plus 6x minus 1. But then this one, you can think of it as maybe the number 1 there. So maybe it's a minus 1 that you are distributing inside the second set of parentheses. So you are doing negative times negative, which will change that to a positive. And you will have positive 62x squared. And then same thing, negative times negative becomes positive. So this will become positive 25. Like I said, if instead of subtraction, you were doing an addition, the signs would not change. But because you do have a subtraction symbol, it works like a negative and it will change the values in your second set of parentheses. So once you have cleaned that up, then you're just combining like terms. Of course, you will see we have a x squared and an x squared term. You want to combine those. So what will negative 6x squared plus 62x squared give us? Negative 6x squared with plus 62.
56x.
Very good, positive 56x squared. There is nothing to go with the positive 6x, so we will keep him as it is. And then, of course, you will see we can combine the negative 1 with the positive 25. So what will that give us? Positive.
24.
Very nice. All right, very good, guys. And we will stop at this example here. They're not really giving us any instructions, so we'll just type it as it is. 56x squared plus 6x plus 24, and you are good to go. So we will pick up from, I think I'm gonna skip the addition, but we'll pick up from the FOIL. So this is what? Section 0.4. All right, so we will do a due date of Friday for 0.2 and 0.3. Okay, so that way you guys can ask me questions if you have any on Wednesday. And then we'll see how far we go on Wednesday, and I'll give you the new due date for the remaining sections.
So
Okay?
the due date or here is it the.
So yeah, so like for 0.1, I made it tonight.
Well, for me, for 0.2, it says
It-
the 23rd.
Yeah, because I just put dates to begin with,
Oh,
but as we make progress in class, I'll change that. So I'll open the 2 and 3.
I gotta make sure.
Yeah, no, you haven't fallen behind. Yes, no, those were just like dummy dates because I wanted to put some date in there,
But we
probably to
still have
scare you guys.
Still the 0.1 though tonight. correct?
Yes,
Okay.
tonight, since we did finish talking about that last Wednesday. Yeah. All right, guys, have a wonderful afternoon and I will see you on Wednesday. Be careful, everyone. Take care.